Hello everyone, we're going to go ahead and do section 6.8, which is solving linear inequalities. So as an overview, congrats! You finished school and are now looking for a job. You decide that the minimum compensation you're willing to accept in salary and benefits is $40,000 a year. Nobody has ever gone into an interview and said, I want $40,000 and I won't accept a penny more. Typically, we would imagine we'd be happy with any amount over 40,000 as well. And that's more of where linear inequalities come in. So we have a little cartoon here. What salary were you looking for? And then we have the person thinking to themselves, greater than or equal to 40,000. They would be okay with a salary of 40,000, but they would also like anything better. What they don't want is anything lower than 40,000. So that inequality where we have x, where x is the salary, we would say we would want x greater than or equal to 40,000 or 40K. So that's where our linear inequalities come in. We've learned a lot about linear equations where they are equal to each other, but our inequalities are now going to take into consideration less than or greater than as well. So for inequalities, we say an inequality is a sentence with less than, greater than, less than or equal to, or greater than or equal to as its verb. So instead of saying like something equal, you would say something less than, something greater than. Then you also have less than or equal to and greater than or equal to. So for example, 3x minus 5 less than 6 minus 2x. Or something like x plus 1 greater than 0. And we have a little key here for what each symbol means. So we see it looks like a little arrow, and what we can kind of imagine is that your little arrow is almost like some sort of animal. Typically we say an alligator, but it's like an alligator. You are going to typically always want to eat the bigger portion. So when we see the little arrow and it's kind of pointing to the left, the mouth is opening to the right there, that means less than. So when we would line it up, we would say x less than a number. Or even if we look at the cartoon, we see the cupcakes, there's a smaller cupcake and a bigger cupcake. So we want to eat the bigger cupcake there. The next one, where it points to the right, but the mouth opens to the left, that is greater than. So then we have another picture of that. This one has pizza. So we see the bigger piece of pizza. The alligator wants to eat the bigger piece of pizza than the smaller piece of pizza. And so that is typically like your mouth or, your alligator wants to eat the bigger one. And then the way that it's pointing is going to kind of give that less than or greater than. So if the mouth is opening to the right, it's less than. If the mouth is opening to the left, it's greater than. So we would say then if we take those same symbols and we put a single line underneath, that's going to mean or equal to. So the mouth is opening to the right there, so it is less than or equal to. So instead of being strictly less than, now we are including the equality. So if we want something like x less than 1, these would include any values less than 1. 0, -1, -2, but it doesn't include 1 because 1 is not less than 1. But if we have less than or equal to, we would include 1. So if we wanted x less than or equal to 1, 1 is equal to 1, so that is included, and it also includes any value less than 1, 0, -1, -2, and so on. So that's what your or equal to means. It includes the number you are comparing in addition to what your inequality is telling you. So lastly there, we have our sign. Its mouth is opening up to the left. That is your greater than. It's got the little line or equal to. So greater than or equal to, less than or equal to, and then you've got less than, greater than. So to solve an inequality is to find all the values of your variable that makes an inequality true. And each of these numbers is a solution of the inequality, And the set of all such solutions is called the solution set. Inequalities that have the same solution set are called equivalent inequalities. So when we solve these inequalities, it's not just a single number that is our solution. We are typically going to have many numbers that count in the solution. So moving into graphing inequalities. Now we can graph inequalities on a number line. So instead of like a graph where we have our x and our y axis, this is just going to use a number line. So in essence, it does make it simpler since we're only using the number line. So a linear inequality in one variable is a statement that can be written in any of the following four forms, where b is a real number and a is any real number except 0. So just, it has to exclude 0 because if a were 0, it would just make your x go away and then you wouldn't be solving for anything anymore. So these are the following four forms. We have ax plus b less than 0, ax plus b greater than 0, ax plus b less than or equal to 0, and ax plus b greater than or equal to 0. So these are the four different inequalities that we can have, and these are all inequalities to 0 in this case. So inequalities are graphed on a number line where we will use an open circle to indicate the value is not in the solution set. This is going to be with greater than and less than. So whenever you graph, there is a slight difference, and it might be a little bit hard to see in the video here, but when we have less than or greater than, no equal tos, that means that when you graph it on your number line, you will put a circle, just a circle, on that value. So for example, looking at our list here of a bunch of different examples, if we go to the second example, x greater than a, we look at our number line, a has a circle on the number line. It is not filled in. That's what we specify with a circle. So the circle is not filled in, but then we fill in the number line according to our solution. X is greater than a, so we should color in our number line for all values more than a. Then we also, the fourth one down, we have x less than a. So once again, we still see that open circle drawn at a, but then it's x less than a, so it's all the values that are going to be lesser than the value of a. So we color in the number line that direction. Now the only difference with a less than or equal to inequality is that it does equal that number that you're using. So we would indicate that with a closed circle or a dot, a filled in circle. So for the very first one that we see here, we have x greater than or equal to a. So since it's the or equal to, we're going to fill in, we're going to put a circle down in a and we're going to fill it in. So it's a solid circle, a solid dot. And then we color in the half of our number line that is greater than a. Same thing for less than or equal to. We have a solid dot at a and the number line is filled in for values less than a. So it's really the only difference between your two types of inequality, your kind of strict inequality and your less strict inequality, your equal to inequality. So if it can be equal to that number, you'll have a filled in point. If it can't be equal to that number, you'll just draw a circle instead. Now we do have a couple more examples in our list here, and the solution set is written next to it as well. We have a couple more examples. These examples are including two different values, so kind of sandwiching x in the middle. So the first one there is a is less than or equal to x, and x is less than or equal to b. So they're kind of all facing the same direction, but so x is sandwiched there in the middle, so you can kind of separate that into two separate ideas. A is less than or equal to x. It's the same thing as saying x is greater than or equal to a. And also x is less than or equal to b. So x can be found anywhere between a and b. A and b are also included, so those points at a and b get filled in. Now, all the four bottom ones that we see there, they are almost all the same. The only difference is a mixture of inequalities. So the second one there, the sixth one down, is that A is less than X, which is less than B. So X is found anywhere between A and B are both not included, so they get a circle, not a dot. Then we have A is less than X, which is less than or equal to B. So now B gets filled in because X is less than or equal to B, but A is not, so A does not get filled in. And then we have A less than or equal to X, which is less than B. So now A is included, but B is not included. And so A gets filled in and B does not. So we can also have a mixture of them if we have kind of these sandwiched inequalities, which we will discuss more later on. But that's kind of what these graphs will look like. You'll draw a number line, you'll find the value that is in your inequality. You'll either do a open circle or a dot, a filled in a point there, and then you'll color in one half of the number line or the other. So, all right, let's go ahead and do some examples together. We're going to graph the solution set for each inequality. We have x is less than or equal to 6 for A and y is greater than -4 for B. So starting with A, x is less than or equal to 6. So first we plot our closed point at x equals 6 since 6 is included in the solution set. X is less than or equal to 6. So 6 gets a closed point. So we see there on our number line, a closed point appeared at 6. Then we want to figure out which direction to color in the number line. This is x less than or equal to 6, so it's the lesser values of 6. So we want to color in going to the left. Left is less. So you can follow that kind of wording there. Left is less. So if it's less, you go to the left. If it's greater than, it's to the right. There's no nice alliteration with that one. But if you remember left is less, then the opposite is true for, to the right and greater. So that's kind of what we want to remember. Another thing that you can keep in mind is that whatever direction your inequality points is the direction you'll color on the number line. So our inequality points to the left, we color in to the left. If your inequality points to the right, you'll color in to the right. So that's the main difference there. So we'll plot our arrow going towards the left since x is less than or equal to 6. So going from our filled in point at 6, our arrow starts at 6 and then goes all the way down. Obviously this would go for an infinite amount of numbers, but we're not going to do that. So we would just end our arrow at the end of our number line. All right, then for B, we have y greater than -4. So since we have greater than, not equal to, -4 is not included in the solution set, and that creates the open point. So that is a circle that is not filled in. So we have a circle that is not filled in at -4, and then it is greater than, so it's going to be filled in to the right. We also see that inequality points to the right. So we plot our arrow going towards the right since x is greater than -4. It's the values that are bigger than -4. So you can also think of it that way. And you just fill in to the end of your number line, and that is about it. So that's how you graph a solution set for inequalities that we have. So principles for solving inequalities. For any real numbers a, b, and c, we have two principles that we can use in order to solve inequalities. Now, for all intents and purposes, inequalities are solved almost the exact same way as equations. We'll do a lot of the same things where we can add or subtract numbers to both sides and multiply or divide numbers on both sides. There's just one very small specific thing that is different that we have to keep in mind. So, for any real numbers a, b, and c, the addition principle for inequalities states that if a is less than b is true, then a plus c less than b plus c is also true. So basically it's saying that you can add a number to both sides of your inequality and it would still be true. Your inequality still works. Now, this is called the addition principle for inequalities. This also works for subtraction. So you could also have a minus c less than b minus c, and that also works even though it's just called the addition principle. In theory, the addition principle works for adding negative numbers which is subtraction. So that works both ways there. Then we have the multiplication principle for inequalities. We say if A is less than B and C is greater than 0 are true, meaning that A is less than B and C is positive, then A times C less than B times C is also true. So if A was less than B and C was positive, then multiplying C to both sides keeps the inequality the same. So A times C is less than B times C. But if you have A is less than B and C is negative, it's less than 0, then your inequality will switch. So you had A was less than B, but C was negative, and so when you multiplied both sides by C, it turned into A times C is greater than B times C. So starting less than turned greater than because you multiplied both sides of your equation by a negative number. That's what you want to keep in mind. These statements similarly hold for A is less than or equal to B. So all of these statements are all true for less than or equal to, greater than or equal to, less than, greater than. They all work the same way. When both sides of your inequality are multiplied or divided, so it's multiplied or divided by a negative number, you have to reverse the inequality sign. So if it was greater than, it will switch to less than. If it's less than, it will switch to greater than. And if they're equal to, it's the same thing. So for an example, if we have negative x greater than 1, we want to get rid of the negative so we can multiply both sides by negative 1. So we'll have negative 1 times negative x greater than 1 times negative 1. The act of multiplying by a negative number switches that sign. So it does turn into x, but it turns into x less than negative 1, not greater than, which it was before. So that is what you want to keep in mind. Basically, inequalities are solved in the exact same way that equations are solved, except for this one stipulation. If you multiply or divide by a negative number, the sign will flip. That's what you got to remember there. All right. So moving on, we're going to do examples together in our notes here. So we're going to solve the following inequalities, and we're going to graph the solution sets. A, we have 5x minus 9 is greater than or equal to 21. And B, we have 16x minus 3x is greater than 40. So let's go ahead and do this together in our notes. All right, so we're solving this inequality here. Like we said, it's really solved the same way as an equation. Remember, the only difference being multiplying or divided by a negative number. So we're going to solve this the same way as we would solve an equation. We're trying to solve for x, and we've got 5x minus 9 is greater than or equal to 21. So let's go ahead and get rid of the 9. We'll add 9 to both sides. Adding 9 to both sides will get rid of that minus 9 on the left. So we'll get 5x greater than or equal to 21 plus 9 is 30. So we have 5x greater than or equal to 30. We're solving for x, so we want to get rid of the 5. We'll do that by dividing. We divided by 5. 30 divided by 5 is 6. We did not divide by a negative number, so that sign is going to stay the same. Greater than or equal to. So we get x is greater than or equal to 6. So now that we know that, we're going to go ahead and draw our number line and graph our solution. So we'll draw a number line. The number that we care about is 6. So as long as 6 appears on this number line, that's really all that matters. So we're going to go ahead and we're going to go from 0 to 10. Right in the middle would be 5. So then 5, 6, 7, 8, 9. So 6 is right here. And then 0, 1, 2, 3, 4. So here's our number line. That's 5, 6. And you can label all of them 7, 8, 9, 1, 2, 3, 4. You can label all of them if you want, but there's our number line. It's going to go from 0 to 10. So the important number we care about is 6. So remember, we always plot our point first. This is x is greater than or equal to 6, which means that it gets a closed point, a closed circle. So we'll plot our closed circle on 6 first. So we'll have our dot there. and then it is greater than or equal to. So we want to fill in our number line for greater than 6 or more than 6. Our arrow for our inequality points to the right, so we color in to the right. You can either just make it just thicker than the line, or you can kind of like scribble it in, which we'll do in the second one, just the slight difference. But there we go, we graphed our solution set. X greater than or equal to 6, starts at 6 and goes to the values greater than. So all right, moving on to B. We have 16x minus, that should be a 16, not a 16x. So hang on one second here. All right, 16 minus 3x is greater than 40. So we're going to go ahead, we're going to solve for x. 16 is does not have an x on it, and so we can go ahead and subtract 16 from both sides to simplify. It will cancel here on the left. We'll be left with negative 3x greater than, and 40 minus 16 is 24. So now that we have 24 here, we're going to solve for x. Now x is being multiplied by negative 3, so we want to get rid of that negative 3. We do that by dividing by negative 3. And we are now dividing by a negative number. So we have our x, 24 divided by negative 3 is negative 8. And what we see here now, we've divided by a negative number, we flip the sign. So instead of greater than, it is now less than. So we put a little star here, divided by a negative number. So we flipped the sign. So we have x less than negative 8. I didn't highlight the one before. X less than negative 8. So we're going to go ahead and graph our solution. So we draw out our number line. Our important number is negative 8. So we just want to make sure that negative 8 appears on our number line. So since we want negative numbers now, instead of going before, like we went from 0 to 10, we can now go negative 10 to 0. So just basically the left side of 0. So we'll put negative 10 down here because your negative numbers always go as far to the left as possible. And 0 is going to be up here on the right. So this would be negative 5, and then we just fill these in. 1, 2, 3, 4, 6, 7, 8, 9. So this is negative 1, negative 2, negative 3, negative 4, negative 6, negative 7, negative 8, negative 9, negative 10. There we go. So we filled in our number line. And now when we write this in, okay, this is x less than negative 8. So it is not filled in because it can't include negative 8. So it's going to be that open circle. So we've got a big open circle here in negative 8. And then it's less than 8. So numbers that are lesser to the left. Remember, less is left. We can also see that our inequality points to the left. So you can either just fill in the line like we did before, just kind of fill it in a little bit, put an arrow, or you can kind of like make like squiggles and put an arrow. You kind of see a difference a lot. Some people do it one way, some people do it another. It's really just up to you. I would say if you can't color coordinate it, maybe do the squiggles instead of just a line, because sometimes it's a little hard to see. So it's really up to you. You can do the squiggles or just a thicker line, and then just make sure to put the arrow at the end of it. So all right, that was our first example there. So let's go ahead and go on back to the lecture. All right, so now we have compound inequalities. So when two inequalities are joined by the word and or the word or, a compound inequality is formed. So starting off with the first, a conjunction. This should actually sound a little bit familiar to you. We did this back in Unit 1. Conjunction, that contains the word and. So for example, something like -3 is less than 2x plus 5 and 2x plus 5 is less than or equal to 7. We can actually abbreviate this by just combining those two inequalities. Since they both share 2x plus 5, we'll just put 2x plus 5 in the middle and make our inequalities on each end. So the sentence -3 less than 2x plus 5 less than or equal to 7 is the abbreviation. So whenever you see it written like that, it means the word and. Then we have the disjunction. That contains the word or. So for example, 2x minus 5 is less than or equal to -7, or 2x minus 5 is greater than 1. There is no abbreviation for disjunctions. So disjunctions will always have the word or in it. And there is a major difference between conjunctions and disjunctions when you graph their solutions. Conjunctions come together, so it'll look like a line segment where there's 2 points and the line is connecting between those 2 points. A disjunction goes in opposite directions. So you have your 2 points and the lines go opposite of each other. So that's the main difference between a conjunction and a disjunction when it comes to graphing them. Conjunctions come together, disjunctions go apart. And we have a silly example here of a conjunction at the bottom. We have 1 fish is less than 2 fish, which is less than 3 fish. So we see multiple fish here. And so that's an example of a conjunction. 1 is less than 2, and 2 is less than 3. You heard the word and in there. So it's just taking 2 different inequalities and putting them together into one. So from there, we're going to go ahead and we're going to do our next example. We're going to solve the following inequalities, and then we're going to graph our solutions. So A is -3 is less than 2x plus 5 is less than or equal to 7. And B is 2x minus 5 is less than or equal to -7. Or 2x minus 5 is greater than 1. So we've got a conjunction and a disjunction here, so we're going to do both of them and kind of see what their difference looks like. So let's go ahead and go on over to our notes. So for part A, like we said before, we have -3 is less than 2x plus 5 less than or equal to 7. So when we solve a compound inequality, you're trying to solve for x, and x will remain in the center. So whatever you do to solve for x, you're just going to do to each end as well as the center. So when it comes to a compound inequality, specifically a conjunction, you're going to do anything in the middle is going to happen to both ends as well. So we have 2x plus 5. We want this to just be x. So let's go ahead and get rid of the 5. If we get rid of the 5, we subtract the 5 from the center, and we also subtract the 5 from both ends. So getting rid of it in the center gets rid of it entirely. But then on our left end, we have -3 minus 5, which is -8, less than 2x, no 5 anymore because we got rid of it, is less than or equal to 7 minus 5, which is 2. So anything you do to the center, you also do to each end. Then, in the center, we have 2x. We want this to just be x, so we'll divide by 2. And anything we do to the center, we also do to the ends. Dividing by +2 doesn't change anything about our signs or anything like that. So we just simplify. -8 divided by 2 is -4. 2x divided by 2 is x. And 2 divided by 2 is 1. So we get our compound inequality, -4 less than x less than or equal to +1. So now that we have this, we're going to go ahead and we're going to graph. We draw out our number line. Remember, the important numbers are -4 and 1. So as long as we graph a graph here with -4 and 1 on it, it's really all that matters. Let's go from -5 to 5. 0 is here in the middle. Let's go 1, 2, 3, 4. 1, 2, 3, 4. So we'll have -1, -2, -3, -4. 1, 2, 3, 4. All right. So since we have a compound inequality now, we're going to start with placing 2 points instead of 1 point. So the first point we have is -4, and it is less than x. So it's an open circle at -4. So we draw a big open circle at -4. And then we have x less than or equal to 1. So that is a filled in circle at 1. So we have our open circle and our filled in circle. Now, looking at our inequality, we're saying that x is greater than -4, but less than 1. And remember what we said, a conjunction connects. It connects the 2 points. So this will be the line in the middle. So there's no arrows in this case. All we've done is connected our 2 points. It's not going off in any direction. This is technically 2 arrows. This is 1 arrow going this way and 1 arrow going this way, but they connect. It's like they connect in the middle and they just overlap each other. So that's why their arrows connect there, and we just see 2 points that are connected. That's what happens with a conjunction. So all right, let's go ahead and go on to B. We have 2x minus 5 is less than or equal to -7, or 2x minus 5 is greater than 1. So the or separates our 2 inequalities, which really just makes this 2 separate inequalities. We're just going to solve each one of them, and we're going to graph them together. So to solve the one on the right, 2x minus 5 is less than or equal to -7, we can go ahead and add 5 to both sides to get rid of it. That gets rid of it there on the left. We get 2x is less than or equal to -7 plus 5, which is -2. And then we're trying to solve for x, so we'll divide by 2. This gives us x is less than or equal to -1, because it's -2 divided by 2. Now, -2 was on the right, but we divided by +2, so we did not have to flip that sign. You only flip the sign when the number you are dividing or multiplying by is negative, not just if the other side is negative. So we have x less than or equal to -1. And now we'll solve the right-hand one. So 2x minus 5 is greater than 1. So we'll add 5 to both sides, just like before. We'll get to x is greater than 1 plus 5 is 6. We want to solve for x, so we'll divide each side by 2. And 6 divided by 2 is 3. So we get x is less than or equal to -1, and x is greater than 3. So these are our 2 important, and you can put an or in there, because this is a disjunction. Too far. There we go. This is our disjunction, so it has the word or in it. So now we'll draw our number line to graph our solution. So the only numbers that we really truly care about are -1 and 3. So as long as we make sure -1 and 3 are on there, that's all that matters. We'll just do what we did before. We'll go -5 to +5. 0's in the middle. 1, 2, 3, 4. 1, 2, 3. This is 1, 2, 3, 4. -4, -3, -2, -1. All right. So starting with -1, we have x less than or equal to -1. That makes it a filled in point. So we get a filled in point at -1. And x greater than 3, that is a strict inequality, gets a circle. And now what we said about disjunctions, when you see the word or, they go in the opposite directions. So we'll just read each inequality, fill them in as we normally would, and it's going to create 2 lines that go in the opposite direction. So x less than or equal to -1, that's less than or equal to less, left. So we're going to go to the left from -1. So we go to the left of -1, and that's one part of our inequality. And now we go x greater than 3. So x is greater than 3, it's values that are bigger than 3. It's not less, so it's not left, which makes it to the right. So we also see that inequality points to the right, so we color in to the right. This one's not as long, but that's okay. It's still on there. That's all that matters. So we created 2 inequalities going in the opposite direction. So that's the difference between a conjunction and a disjunction. Remember, conjunction connects, disjunction goes the opposite ways. And so there we go. That's how we do a disjunction and a conjunction compound inequality. So, all right, we're going to go ahead and go back on over to the lecture. And we're going to do another example. So, for her interior decorating job, Natalia can be paid in one of two ways. Plan A is $250 a flat fee plus $10 per hour. Plan B is just $20 per hour. So suppose that a job takes n hours. For what values of n is Plan B better for Natalia? So for both of these plans, we're going to have to create some sort of expression for each plan, and then we're going to have to set up the inequality between those two expressions to figure out when Plan B is better, so greater than. So all right, we're going to go ahead, we're going to go over into our notes to do this one. All right, so we're going to need to create the expression for each one of our plans. Plan A is a flat fee. So she earns $250 just by showing up. And then she earns an additional $10 for every hour. So if we have n hours, that's going to be 10 times n. If she works 2 hours, she'll earn $20, 10 twice. So we have a flat fee of $250 plus 10 times n. So that's the expression for Plan A. Now Plan B doesn't have a flat fee, it's just $20 per hour. So if we work n hours, we would multiply the number of hours by $20 to figure out how much she made. So that's just 20n. And this problem is asking us when is Plan B better or greater than Plan A? So we can go ahead and fill in the expressions that we found for each of them. Plan B, like we said, was 20n, and this should be better than Plan A, which is 250 plus 10n. So this is the inequality that we need to solve. So we're going to go ahead and we're going to start solving it. Now we want to bring all of our n's over to one side and all of our non-n terms to the other. So let's go ahead and subtract 10n from both sides. It will cancel out on the right, and 20n minus 10n is 10n greater than 250. So then we just need to know when is 10n greater than $250. So we'll go ahead, we're going to solve for n. So we're going to divide by 10. The 10 cancels on the left there. And we get n greater than 250 divided by 10 is 25. So we say that n greater than 25 would satisfy our question as when is Plan B better than Plan A. So then that would make it so that when we solved, we got 25 and is in hours. So as long as she works 25 hours, really, or more than 25 hours, that's when Plan B becomes better than Plan A. So we'll go ahead and write that. This is our solution here for our answer, but we'll just write this in a sentence format since this was a word problem. So we would say Plan B is better if Natalia works more than 25 hours. So if Natalia knows that this part-time job is only going to be a 20-hour job, she should definitely take Plan A. But if it's going to be more like a 30-hour per week job, then she should definitely take Plan B instead. So, all right, there we go. That's how we did that one example. So let's go ahead and go on back to our lecture. And that wraps up section 6.8. So in summary, we learned how to graph solutions for simple and compound inequalities, solve linear inequalities in one variable, solve compound inequalities, and solve problems using inequalities. So there we go. That was section 6.8, and I'll see you in the next one.